So, hello everyone again. This is lecture 3 part 1 of dual nature of radiation and matter. Let us go on with our further discussions of this topic only. So, I am Sameer Lavankar. Let us begin our discussion. So, first of all, a course outline for you. So, we started with the introduction in which we understood the concepts or basically the timeline history of how this concept came into picture. Why was there a reason to find out what is actually happening in a complete cathode ray tube experiment, etc. What actually happened before the discovery of electrons and so on. Okay. So, now after that, in second point of electron emission, we understood that how a little there is a potential, there is a work of potential, there is a threshold frequency at which that amount of frequency is required, so that the electron can get out of the metal surface. Okay. Basically, before when these concepts were being understood, then there was no such discovery that these particles are called as electrons only, because this complete experiment was being done before the discovery of that negatively charged particle are called as electron by J. Thomson. Therefore, everything was called as was being understood as in some sort of similar particles are being observed when the experiments are being done by different arrangements. So, after that, in this electron emission, we understood basically that the amount of energy required for the electron to be emitted out of the metal surface and so on, and basically that thing is called as electron. Okay. Then the third point of photoelectric effect, we understood the basics of photoelectric effect, as in that there are different metals, and then when they are irradiated by light, then the electrons get ejected out. Electrons get ejected out from the plate. That plate is called as the emitter plate, and then generally this experiment was being done in a circuit, in which it was found that the electrons are being passed, or let us say they are moving from the emitter plate to the collector plate, and as the electrons are being moving, there is a constitution of electric current, and hence the circuit is completed. So, these all things were being explained. So, basically this phenomena in which the electrons are being ejected out from the metal surface when it is irradiated by ultraviolet light, or let us say visible light, depending upon the metal surface, then that phenomena is called as photoelectric effect. Okay. So, basics of the photoelectric effect were being understood in the third point. After this, we understood the experimental study of photoelectric effect, in which we understood what happens when we try to change the intensity, what happens when we try to change the frequency and so on. So, basically the concepts of change in the intensity or frequency on the retarding potential and the value of saturation current, etc. were being studied. So, we basically defined 2-3 different concepts such as saturation current and retarding potential, etc., which were clearly discussed in the previous lectures, in which we understood this fourth point. In the last part of the last lecture, we started with the fifth point, that is photoelectric effect and wave theory of light, in which we are basically understanding as in which you have already understood in the topics of your ray optics and wave optics, as in that light is generally accepted as a combination of both discrete particle theory, that is Descartes theory, and wave particle theory. So, how can that concept be accumulated or can be conceptualized in this complete lecture is the complete order of 5, 6, 7, 8 everything, which we will study after this fifth point. Okay. So, let us not waste any further time, let us start the discussion directly from the fifth point where we ended in the last class. So, photoelectric effect and the wave theory of light. So, I guess these all things were completed in the previous lecture only. So, what was the conclusion? So, first of all, one should remember that according to wave picture of light, so basically I am iterating this one. So, according to the wave picture of light, the free electrons at the surface of the metal over which the beam of radiation falls absorb the radiant energy continuously. Okay. So, basically what is we basically understood this all concepts as the accumulation of kinetic energy by the particle. So, as this absorb, so that is being denoted by kinetic energy being absorbed. So, as it has the energy, so basically the amount of energy, if the energy is more, depending on if the threshold frequency is being intact, then if the frequency is more than that, then the electrons can get ejected out. Okay. So, in this picture, the maximum kinetic energy of the photoelectrons on the surface is then expected to increase with increase in intensity. So, these all things are already been understood in the experimental study, that with the increase in intensity, the amount of the rate of electron emission per second increases. Okay. Final conclusion is that also no matter what the frequency of radiation is, a sufficiently intense beam of radiation should be able to impart enough energy to the electrons, so that they exceed the minimum energy needed to escape from the metal surface. Okay. So, sometimes it is independent of frequency, sometimes it is independent of intensity. Okay. So, generally for the photoelectric emission to take place, a little a minimum threshold frequency has to be there. After that, it does not depend if the intensity is even dim or it is very higher, the photoelectric effect will take place. Okay. So, let us move on with the further discussions now. So, right now what we are telling about is, let us move on with this discussion. So, a threshold frequency therefore should not exist. So, what they are trying to say is, for now if let us say we are conceptualizing this concept here, then according to that, what does the last line say here, that no matter what the frequency of radiation is, a sufficiently intense beam of radiation should be able to impart enough energy to the electrons, so that they exceed minimum energy needed to escape from the metal surface. That means they are just trying to say in very simple terms that there should not be a threshold frequency. Even if the frequency is very less, then also the photoelectric effect should take place. But why it does not take place is the conclusion, or is the procession which we need to, which we will try to understand in the subsequent slides. Okay. So, this is the only crux. Let us start with the further discussions now. So, a threshold frequency therefore should not exist. These expectations of the wave theory directly contradict observations 1, 2 and 3 given at the end of the subsection, that is the effect of frequency of incident radiation on stopping potential. So, basically what they are trying to say is that if we try to assume, or if we try to relate to this concept which is being studied in the previous slide just now, then that concept in which it is told that the frequency of incident radiation should not be that means that photoelectric effect should not have a threshold frequency value, it should be starting from any value, but that is contradicting the previous statements which was already experimented. So, basically that thing is only right, in which the threshold frequency should be applicable, but how to prove that, or how to conceptualize this concept here. So, just let me go on, then you can understand it very clearly. So, further we should note that in the wave picture, the absorption of energy by electron takes place continuously over the entire wavefront of the radiation. So, again a theoretical portion only, so you should just understand this, because main concept will be after this. So, further we should note that in the wave picture, the absorption of energy by electron takes place continuously over the entire wavefront of the radiation. You may have heard of the concept of wavefront. This was been clearly explained in the concept of wave optics, in which these are the basically wavefronts being made. So, spherical wave, this is basically spherical wavefront, and if the radius is increased very high, then the plane wavefront can be visible. So, these are basically plane wavefronts. Okay. Let us say this is the direction of propagation and these are the plane wavefronts. Okay. Since many electrons absorb energy, the energy absorbed per electron per unit time turns out to be very small. Fine. Explicit calculations estimate that it can take hours or more for a single electron to pick up sufficient energy to overcome the work function and come out of the metal. So, officially if we go with the exact calculations, it was being found that the energy absorbed per unit time is very less. So, if we take into calculation that thing and the amount of energy required for the electron emission to take place, then it will take a large amount of time, but majorly it happens in an instant only. So, what is the thing we are lacking right now? So, we are just looking towards that lacking portion in the subsequent slide. So, just wait, let us theorize it first and then we can go on with the complete discussion further. So, this conclusion is again in striking contrast to observation 4, that is observation 4 is that only that, as we have understood in the previous lecture, that there is a time lag, very less time lag. When it was calculated, it was found to be 10 to the power minus 9 second, which is very small. It is 1 upon 10 to the power 9 times of second, which is very small portion. Okay. Again, so this and this thing get contradicted. So, why it is happening, we will try to understand it further. Okay. So, this conclusion is again in striking contrast to observation 4, that the photoelectric emission is instantaneous. Okay. So, photoelectric effect is instantaneous. In short, the wave picture is unable to explain the most basic features of photoelectric emission. Okay. So, what does it try to say? So, basically what we are trying to say, that this wave theory of light is not applicable or is not able to explain this basic concept of photoelectric emission. This complete emission is happening due to light only. So, these concepts of light should be able to be explained by wave theory, but there are few contradictions which are directly visible here. So, why are these contradictions, what was being done, what was being conceptualized further will be explained in the subsequent slides. Okay. So, just for now, in this 2 slide of discussion, what we understood is that wave theory of light basically contradicted for major basic observations such as time lag, such as these values in which it was being told that threshold frequency should not exist, etc. Okay. So, why was it happening? If it is applicable, I will try to explain very clearly. For now, let us move on with the subsequent slides. Okay. So, till this present slide, we understood that the wave theory of light was being tried to conceptualize the concepts of photoelectric emission, but major basic ideas were not being understood or not being explained clearly by the wave theory of light. Okay. Let us move on then. Okay. So, now let us start first of all with the Einstein's photoelectric equation, and then let us go with the basics of everything which basically Albert Einstein tried to prove to us. Okay. So, what he basically did was all the concepts, all the experiments which we did for photoelectric effect, he tried to mathematically formulate it. So, basically you will heard of equations here, very small equations, nothing very typical. So, basically we are just trying to make a mathematical input of the complete concept which we heard or which we learnt in the last 2 lectures. Okay. So, let us start the Einstein's photoelectric equation. Please be very careful while reading everything, because this is the main crux of this complete chapter, that is Einstein's photoelectric equation. Okay. So, let us start. So, in 1905, so please remember, so it was on the starting of the 20th century. Okay. All the things of electron emission etc. were being just before the end of the 19th century, and this thing was started at the start of the 20th century. Okay. So, in 1905, Albert Einstein proposed a radically new picture of electromagnetic radiation to explain the photoelectric effect. So, now he started to conclude in his way. So, in this picture, photoelectric emission does not take place by continuous absorption of energy from radiation. Radiation energy is built up of discrete units or so called quanta of energy of radiation. Okay. Let us look back. So, first of all, what was being done here? If it is written here, it would have been written that we are assuming it to be continuous absorption. I guess it is not written, so that is why. So, this is one of the basic idea. Okay. So, I will try to understand, explain it only. So, what till now, till 1905, when Albert Einstein did not propose his idea, it was being understood, or it was being understood that the complete energy being absorbed is by continuous absorption. But actually what is happening is that small discrete units which he called, or which he defined as quanta of energy, was being irradiated with time, and those were being absorbed. Okay. That thing was not being incorporated in this wave theory of light, and that was a little bit of this variation which we tried to, which was being observed in the complete discussion which we did just before the starting of this lecture. Okay. So, first of all, let me just read this thing only. So, basically what was understood previously, that let us suppose this is the complete radiation of energy which is being interacted. Okay. So, this is just a way, let us say, right now what we are doing is we are trying to discretize it. So, basically what is happening is this has been divided into very, very small particles which Albert Einstein denoted as quanta of energy. So, this is that energy being irradiated from, let us say, point A to point B. So, in this picture, photoelectric emission does not take place by continuous absorption of energy from radiation. Radiation energy is built up of discrete units, the so called quanta of energy of radiation. Okay. Each quantum of radiant energy has energy h nu. So, now please be very careful in conceptualizing everything. So, right now what he is saying, so what I made, let us say I make a diagram again. So, let us say this is the direction of passage of energy, and we are assuming these to be quanta, let us say these are small quantas, right. So, each of this is having an energy of h nu, right. What is h, what is nu, I will try to explain. So, what is the value of h also, you should need to remember that. So, each quantum of radiant energy has energy h nu, where h is the Planck's constant. So, this you may have heard in your chemistry classes also. So, this is basically Planck's constant. Right, and nu is the frequency of light. Okay. So, basically nu depends upon the different light source, different lights which are being input from the source. So, this is basically frequency of light. Okay. So, each quantum of radiant energy has an energy h nu, where h is the Planck's constant and nu is the frequency of light. In photoelectric effect, an electron absorbs a quantum of energy h nu of radiation. If this quantum of energy absorbed exceeds the minimum energy needed for the electron to escape from the metal surface, which is called as work function, which you already understood in the starting lecture, I suppose. Work function phi naught, the electron is emitted with maximum kinetic energy equal to k max, which is equal to h nu minus phi naught. Okay. Let me try to make it as an example. Let us say the value of h nu is, let us say 5 electron volts, right, and let us say h nu value is 5 electron volt, and let us say phi naught value is, let us say 7 electron volts. Okay. So, what happened was this quantum of energy came, it collided with the electron, the energy was being distributed, or energy was being absorbed by the electron. Now, what was the work function? It was being calculated, work function was 7 electron volt. So, what basically was happening, that let us suppose the electron was trying to go out because of its energy increase. So, it was trying to go out of the metal surface, but because the work function was very high, that means the repulsive was very high, it was being interacted. So basically what is the mechanism happening there? So basically mechanism is happening there that when this negative charge was trying to go out, the positive charges were being built up, which was trying to move it inside the what we can say metal surface only. Now let us suppose more energy came, so more quanta of radiation was being absorbed, and finally the h nu value was equal to, let us say, 9 electron volts. Okay. So now what is happening is this energy is being absorbed. Now when it was trying to go, then the amount of attraction, or let us say the amount of energy which this electron had through go out from the electron surface, from the metal surface, is greater than the repulsive force, and hence this electron was being ejected out with a maximum value of k max, which is equal to 2 electron volts. So this is just the complete mechanism and understanding of how this equation is working. Okay. So till now what we understood is that this k max is equal to h nu minus phi naught, where phi naught is the work potential. Okay. So let us say this thing is also explained. More tightly bound electrons will emerge with kinetic energies less than the maximum value. Note that the intensity of light of a given frequency is determined by the number of photons incident per second. Okay. What is this photon? I will try to explain it much clearly in the subsequent slides. For now you can just theorize it. So what is actually being written here, that the intensity of light of a given frequency, please remember the frequency is not being changed till now. Okay. The intensity of light of a given frequency is determined by the number of photons incident per second. Okay. Increasing the intensity will increase the number of emitted electrons per second. So this is the basic crux which we also studied in the experimental study only. Okay. So now till this present point, Albert Einstein's equation, Albert Einstein's theory was being devised, which was being accurate enough with the experimental analysis. Okay. So what we found out that with increase in the intensity, the value of emitted electrons per second also increases. Okay. However, the maximum kinetic energy of the emitted photoelectrons is determined by the energy of each photon. So basically the total kinetic energy or the maximum kinetic energy depends upon the what we can say, the individual electron particles energy. So maximum energy is depends upon, so let us say there are measure of the electrons are being ejected out. So maximum kinetic energy is determined by the energy of each photon. So basically we try to add up and then we can find out complete maximum kinetic energy. Okay. Above equation is known as Einstein's photoelectric equation. So this is the basic crux, this is the basic idea that Einstein tried to explain to us people. So and hence this equation came to be known as Einstein's photoelectric equation. Okay. We can now see how this equation accounts in a simple and elegant manner all the observations on photoelectric effect given at the end of subsection, that is effect of frequency of incident radiation on stopping potential. So basically what concepts were being conceptualized in the experimental study analysis are being explained here. So basically what is the crux of this idea? You should first of all remember for what is the first explanation or what is the first idea which Einstein gave, that it is not that continuous absorption of energy takes place by the electron. The energy is being absorbed in terms of quanta of energy. It is absorbed in discrete way, and hence let us say it absorbs first one h nu value, then 2 h nu value, then 3 h nu value, etc. Let us say if I denote h nu as constant value, let us say k value. So it absorbs that discrete particle again, then it absorbs again and discops again, and then at some time it comes that its value increases and goes further from work potential value, and hence this thing can be conceptualized here. And finally, as far as exams are considered, you can just remember this equation, that is k max is equal to h nu minus phi naught. What is h here? Planck's constant. What is nu here? Frequency of light. What is phi naught here? Work potential. Okay, and hence the maximum value of the kinetic energy can be obtained. Okay. So let me stop it here only. From this point, from this slide I will start from the next part of this lecture only. So till now what we have heard is basically first of all we tried to find out that the wave theory of light could not conceptualize each of the basic concepts. There may be major drawbacks which we need to understand, and then we can try to revert back with the wave theory of light and understand why those concepts cannot be explained directly. Okay. And finally we started with the Einstein's photoelectric equation in this part only, which is k max is equal to h nu minus phi naught. Some major modification will also be done in this equation, and then majorly 2-3 equations will come into picture. So basically you need to remember just 2-3 things, and hence the numerical part of this complete chapter is over. Okay. So let me stop it here only. So thank you so much.